All right. Hello. So yeah, I'm still not back up and running routine wise, but I'm getting like it's amazing with AI, the stuff you get done. So yeah, I'm like I need to exercise my brain, so this is the project I'm using. But I think we're onto something, and I made some adjustments since last time we streamed about this. So one thing is like I kind of, for me, open source projects is as much about messaging as an inspiration as it is to be like potentially a valuable tool. So this is why I'm like packaging everything up into something that can be a valuable tool, but it's not like a failure if no one adopts it, because the most important thing is the messaging. Like, do people take inspiration from this? Do they reflect on why things are the way they are, and so on and so on? So anyways, so I registered the domain name RASK UI, and then I put Claude to work, and it built this website. And I also put together some slides. Let's see. Yeah, this is just the different things. But I think, oh, here's API reference. Oh, it goes, okay, cool. Anyways, and then I put together some slides, because I think this is the most important thing. If you do create something valuable, this is true for any kind of product, you can't be the one that kind of puts it on the map. It needs to become this viral thing. So what I've learned, I can't say I actually have a success story of it, at least not yet. But what I've learned is that you need to provide resources for people to kind of spread the word if it's worth it, right? So that's what I'm doing. That's why there's a website. That's why there's slides. So it's like easy for people to, if they like the approach and they like the tool, to kind of tell other people about it. But I thought I would go through the slides, because the whole point here, the whole conclusion is that reactive state management is really, really good. But also a reconciling UI is really, really good. Like, if you want to if you only want to build UI without state management, like, React is awesome, because you just have these functions. You can use the full power of the language to describe that UI, but it's horrible at state management. And then you have something like Solid, which is fully reactive, not just state management, but also the UI. And it's great for the state management, but it becomes quite magical for the UI part. Like, it has these custom components. The code you write is not really the code that runs. There's some compiler magic there, which you can accept, as you do with templating languages, which is fine. But for me personally, if I'm writing JSX, I want that to be like actual JSX, in the sense of like the mental model. I don't know why I'm talking. Why I can go through the slides. Anyway, so the point is that with React at 16.7, we had this like concept of hi Adam. We had this concept of class components, and it was actually a really, really good abstraction for state management, because you had explicit lifecycle hooks. You had like this class structure of like methods. You had your state and everything. And then you had these like pure components that didn't do any state management, but could kind of like reflect your UI. And I remember at some point you kind of used the classes for state management, and then you use the functions to actually describe UI, which was just a really nice separation, like conceptually. And then React wanted to make those two things one thing. And the great thing they did is that there was just like one paradigm. It was just a functional paradigm, so you didn't have to move between classes and functions. But maybe the most important thing that happened that is not highlighted enough, I think, is that they solved state composition. Like if you think about a class, like how do you compose functionality into that class, right? You can't extend. That's a really bad composition model because you can only extend one thing at a time. At some point, even before this, they had like mix-ins, if you remember that. But that was also a really bad model because they would like override each other and typing was horrible, and so on. So when they introduced hooks, as horrible as they are in terms of mental strain, it solved state composition. Like it's a beautiful concept that you can just bring in these functions that does their own state management. You can kind of just bring it together into the component. And it works with typing. There's no like overriding or anything like that. It's beautiful. And this is why Vue adopted it as well. Like Vue didn't implement hooks in the same sense that React did because it's not doing reconciliation the same way. But it's the composition, right? And that's why they called it the composition API in Vue, because it's a really good composition model. Anyways, the thing about React is that they chose to put this inside the reconciler or make it part of the reconciler. So like the function is called again and again. And when you put that state management in there, what you get out of it is tail closures, dependency arrays. You don't have lifecycle hooks, or at least explicit lifecycle hooks anymore, which I guess ties also into concurrent mode. But then you see all these band-aiding hooks as well. Like it's functionality that has nothing to do with your app. It's there for the framework. Like use callback, and they had this like memo, for example, and they just introduced this like use event, which was only there to band-aid challenges with referencing things from a closure. Like it's like, yeah, it's just really bad. And I can't believe they get away with this. It feels strange to me. It very much feels like people are like so locked into what React is now that they don't step outside and take a look at what they need to deal with in terms of developer experience. Anyways, and then you have the opposite approach where you don't have a reconciler. You have reactive state and reactive UI. And you still have a single functional paradigm, which is great. You have state composition, but instead of like calling it use something, you just say create something. But it's the same concept. Though when it's reactive, you have explicit lifecycle. So you have the function itself is like when things kind of, you have an on-mount hook or whatever you want to call it. And you have an on-cleanup hook. Maybe I should put that in the slide there. So that's, I should do that. So that's really, really good. Another thing is that it's insanely performant. Like you can't get anything, like a virtual DOM is heavy or has a cost. But with complete reactivity through state management and the UI, you get the absolute best performance. But there's a cost to this as well, which is that even though the state management is very clear and concise, sorry, it's my... The reactive UI is like magical. Like if you think about the mental model of a reconciling UI, you have a function that returns some UI. When something changes that requires that UI to update, the function is called again, and the reconciler compares the current UI with the new UI with the old UI and makes the minimal updates. Like, this is a very simple mental model. But when you think about reactive UIs, it's very hard to reason about what actually happens here. So it looks like you're returning something static, and from a runtime perspective, you kind of are, because you're just returning this UI once, right? So when you're calling this count, you're actually extracting the current value, which is 0. So you're statically returning 0 here, but it's not really what's happening. What's happening under the hood is that the compiler changes this into a count, which is a function call. So you have a child that's a function that's being treated as like its own like observable scope, and optimally updates just that like area of the DOM, which is great, but it's like, it's harder to reason about, I think. And then since you have reactivity, you and the function is, like, you can't compare the new with the old. How do you do things like lists and conditionally showing things and stuff like that? So you need these special reactive components to do that. And then it's hard to reason about exactly how they work, because also there you have like, for each component, you kind of pass in the reactive value, but you like call it, but it's not a function that it's compiling to. It's just referencing the actual array. Like, I should have had some code here, but the point is that it looks exactly like the count, but the count actually translates to a function or compiles to a function, but the array doesn't do that. But because it is an array, it's able to, like, the component can access the array and do its magic inside of it. So it's like, yeah, there's like magical stuff happening. And then you have unexpected runtime behavior, which you see with like destructuring props, for example. Suddenly it just breaks, like nothing's updating, and it was just because it destructured something. So when you do reactive state with a reconciling UI, it's not about like solving, it's not this it's not this silver bullet. Of course, nothing is, but it's about like minimizing the mental strain. So here we have all the good stuff, but we still have, well, to explain it first. So you have a component that's still a function, but that is its setup scope. That's being run once, right? And then you return the function that acts as the reconciling UI. So the return function is called again and again based on whatever state it accesses. But now you have like a clear concept of reactive state and a clear concept of a reconciling UI. And it's still just a single functional paradigm. It still has the full power of state composition. It has explicit lifecycle management, and it's still insanely performant. Like, it's not as performant as a completely reactive solution, but it is way more performant than a purely reconciling solution. The caveat is that you cannot destructure reactive objects. So you should never destructure state, props, or any of the other reactive objects. So what we can do here is still have a concept of stateful and stateless components. So the only thing that differentiates them is if you return a function or not. So if you have a component where you return a function that describes the UI, that becomes a stateful function, where the function body itself is the setup phase and the return function is the reconciling UI. Or if you don't return a function, you can't like put any state in there, nothing. It's like the purest version of a component that you can imagine. And all of this is based on Inferno.js. Sorry, this is a really bad presentation. I just have to read through it. And then you have like the primitives, which is you have the context, and then you have like the component where you can inject stuff into the context so that child components can get from the context. You have state, create computed, create view, which is really a utility to put different reactive objects into one object. And then you have async, you have query, you have mutation, and all of these are considered reactive objects. So that's also a thing that I think has been like a little bit all over the place. Is like, how do you consume reactive state? Like you have Solid, which has a mix of calling, like I should have got code here. But Solid has like a similar signature to useState, right? But the value is a function. To set the value, you have a different function, like in the destructured array, to set the value. So that's like one type of signature. But then you have something like preact, which returns a single object, but that object really acts as a reference. So you have like count.value. So you always do like dot value. And I can't remember if they have the same like a separate set function or if you can just mutate dot value. I can't remember. And then there's another approach to this where you have like an explicit set and an explicit get. But I think the cleanest way to do it is to just have objects. You kind of force to have objects. So you can never create state without using an object. So even if you just want a single count, you still create state with an object with a count key. And the same for computed. When you create computed, you need to create this object that acts as the host for the reactivity. So again, if you want a single computed, you would still create an object and so on. And async, query, and mutation are naturally objects because they have like an is pending and so on and so on. The nice side effect of that though is that every time you point to something reactive, you point to it through its host. So you always say like state.count or computed.doubled or whatever. So in your code, you more like when you destructuring is nice, but you lose context when you destructure. You don't know where the value is coming from, reading the line where you're consuming the value. So yeah. Anyways, so then you have create effect, you have create mount effect, and then create cleanup. I didn't want to do on mount and on cleanup like Solid does because it's just inconsistent. So this is something that's kind of value of this project is like consistency. So that points back to reactive objects. Like everything that's reactive is an object, and all the utilities are like create utilities. So when it comes to composition, just like hooks, you create these functions, but you call them create something, and you do all the state management you need to do. You can put effects in there, whatever you need. And then what you can do is return a view, which is a combination of any reactive objects or any plain objects. So you kind of get this composed single object that represents that thing or that counter in this case. And then you can choose if you just want to consume that counter directly, or you can inject that into context so that it's available to any nested component. Yeah, and that's basically it. But the cool thing, okay, so that was kind of just going through the presentation, but the cool thing is we changed something. So last time the library was just running Inferno, and we were using the JSX transpilation of Vite or ESBuild and calling our own JSX helper, mapping into Inferno. But that adds some overhead, actually quite a bit of overhead. So the way Inferno actually works is that it has its own bubble plugin. And what it does is that it converts JSX through that bubble plugin. So it's not like ESBuild transpiling JSX into this like JSX runtime kind of thing that React does and many others. It just does its own transpilation. So basically what it does is creating these V nodes, and they're highly optimized. Like this is what Inferno really nailed, is performance, like how, as efficiently as possible, generate these V nodes. So that's what's happening here. And the library now exposes a plugin that you can use with Vite. And the only thing that was added is that we identify this signature. So first, the actual Inferno Rust plugin runs through, converts everything to these highly efficient V nodes. And then we have a custom plugin that goes through and checks if there's a function that returns a function with V nodes. And if that's the case, it replaces this counter state with an actual like RASK component, which has a setup. So we should have, sorry. So you kind of have this code, and this translates to class counter state setup equals boop. It's a very simple transformation. This is all it does, and that makes it stateful. Counter state extends RASK component. This is what it translates to. So this is how it achieves being able to have stateful components and stateless components. Like you can't do this without a compile step. But since Inferno runs the fastest using its own compiler, so there's like Inferno runs faster. You don't have to configure. Well, that's not true. You still have to configure TypeScript with JSX. Yeah, that's not really true. But I think that was the excuse. It was like, okay, how can we get as close to Inferno performance as possible? Well, we need to use their Rust plugin. And then if we need to do that anyways, we can enable this. And I think this is kind of important. One thing is like it will be more performant, but also being able to reason about there are certain components that are actually pure. And this is a discipline in React because any component can become stateful. Well, now you have like a true separation of pure and stateful components, which I think is a good thing. Yeah, and then another thing. Why is this? Oh, is this the slide icon? Yeah. How do we get back to that? There we go. So another thing I also added is a create one. So you can do npm create RASK UI, and then it will do the thing you expect it to do. A cool thing is, so it asks you if you want TypeScript or JavaScript, and then it asks you, do you want to do it in the current folder or do you want to put it in a new folder? This is the thing that's bothered me the most about these create tools, is that you don't know from the get-go where it's going to put your project. Some of them puts it in a nested folder. I think most of them do. You can still pass like the folder name when you do npm create, like RASK UI space some folder. But if you just run this command, it's going to ask you if you want it in the current folder or a nested folder, which I think is brilliant. Yeah, I can demo that. Let's see. Hopefully it works. Yeah, I guess I can just do it here. Okay. So if I do npm create RASK UI, I only tested this locally, so hopefully it's working. Yep. So here I can choose TypeScript, and then it asks if I want to do it in the current folder or a new folder. If it's a new folder, my RASK app. And it installs the latest version. And then we can go to my RASK app, npm run dev. Boop. And it shows this relatively ugly. Oh, what happened to my camera? Oh. What the hell just happened? Sorry about that. Let me see if I can fix it. Disconnect. That was weird. But yeah, it creates that relatively. No. Did I lose my camera now? Video source, Christian's iPhone. Oh. That's my partner, by the way. What the fuck is going on? Oh, that's my actual phone. What the hell is going on? Oh my god, I can't believe this. Well, I shouldn't show my phone. It should be my camera. Yeah, that's my studio. Oh my god. Let me try to. Okay. If I did. Oh, there we have Christian's phone. No, that's my iPhone camera. Oh, what the hell? Oh, this goddamn stream. I have no idea what's happening here. Isn't that typical? Studio display camera. Yeah, maybe we can just use that. Yeah, I have no idea what's happening here. It seems to be going this like side view or something. I turn it off, put it on the side, and it's supposed to show my camera, but it okay, whatever. Okay, I just have to use this shitty thing. Ah, that sucks. Anyways, yeah, so you kind of get into like a demo app, which is like silly, stupid, but it works. It's a nice way to get going with something. So yeah, what I thought we could do is we can actually go into, oh, I can't deal with this. Let's see, I'm gonna try once more. I'm too vain for this. Or it's actually more people like if they visit the stream and they see me like not having proper setup. It's like, who is this guy? I can't believe this. Okay. Camera. Well, I think we just have to. God damn it. Is that typical? Yeah, what an amateur, right? Okay, let's use the ugly camera. Can I still mirror this, by the way? More options. Blend mode, transition, shadow. I think I should be able to mirror this. Where is that? Yeah, the magical picture mirror. Yeah, there we have it. Okay, looks kind of shitty. Look at that. Anyways, damn amateur. Let's go and try to actually look at how this would actually look in something real. This is something I'm excited about. Let's see. Let's go to... Oh, don't I have Divergent to-dos open here? Oh, it's so sad. Like the Divergent to-do... There we have it. The Divergent to-dos project. Like I was so on a roll with it. And then all this like kids getting sick and me getting sick and my partner getting sick and the kids getting sick again and the kids getting sick again. Like everything completely stopped, which was really sucky. Okay, I'm gonna just reset all of this, check out. But I hope to get it back up to speed. RASK UI. So let's just do a git clean fd. Let us do, is it npm? No, it's pnpm. pnpm add RASK UI. And then, oh yeah. I haven't worked on this for a long time. Oh. And then the only thing we need to do is... So we're not actually going to run it. We're rather going to reflect on writing code, but I can kind of show how you set it up. Rask plugin. So we just set it up like this, I think. Oh, sorry, /plugin. And then in the ts config, which I guess will be app. And then I think you need JSX import source would be RASK UI. Yeah, whatever. We're not gonna actually run it for now. Let's just look at how the app works. So we have this cache provider. We have the app. Is mobile device. Where's that coming from? Oh my God, this is a lot of stuff. Okay, interesting. So we have something called is mobile device, which is like currently hard coded. So if you change the size of the app, it doesn't actually. Hi, Eirik. So if you update the size of the browser, it doesn't actually bounce back and forth between mobile and desktop. So one thing we could do here is to actually have sorry. Yeah, is to have like a utility for that. Okay. So we can just do it inline for now. Oh my God, there's so much stuff here. Where's the freaking app? There we go. Okay, so what we could do is like create device or something. And then what we want to do is we want to create some state for this. And then is mobile. And then we need a function. And you know what? I'm going to do my constructor pattern thingy here. So I'm going to say is mobile. What should we call this? Check if mobile or something. Check if mobile. And then we're going to go and find our is mobile device. Oh, you know what? Let's rather just do this. Create check mobile device. Let's just do this. And then we're going to do const state, create state is mobile. Device. Oh, I guess I need to rename again. And then this is the actual check that we need to do. So let's just return the state, and then we're going to do function check mobile device. Let's put that in there, and then we're going to run that immediately. But we also want to make sure that if you change the what's it called? Change the size. So that would be like window add event listener resize. We're gonna go and yeah, and then we could like debounce this, but we're not gonna because we're just writing some code. But we're gonna say state is mobile, check mobile device. So this is what I like about, you see how much code that goes into like actually checking this. Well, now we can see like the actual functionality of this, and then this is like an implementation detail, which is nice. Anyways, that's really unrelated to this, but cool. So what we're gonna do here, we're just gonna take this thing, we're just gonna return this instead. Oops. Oh, did I do oh, sorry. Oh, come on. My bad. So this is the thing, right? I can actually write an if statement here. Actually, 2 of them, which is amazing. And then check mobile device, create check mobile device. This is really bad naming. This is something I'm adjusting to. Like that. And now we have a reactive check for the mobile device right here. Yeah, I'm thinking it should probably be like some kind of environment. Yeah, let's do that. Let's call it rename, create env. Isn't that amazing? Is electron. What was that electron check? That doesn't change, so just keep it right there. And then we're gonna call env. Env is electron, and oh, is electron. What we're also gonna do is that we're gonna create, oh, this is fun. Here we're gonna create a context, export const env context. Create, oh, it's a lot of create context. And this is basically gonna be the type of env, which is mobile, boolean, is electron, boolean. That's what we're gonna expose. And the question now is, Should we inject the context already here? We can try that first. So we're going to say, instead of create env, we're going to say inject env. And then instead of returning state, we're going to say env context inject. Return, oh, sorry, inject state. And then in our app, we're not gonna, oh, that's interesting. We should change that. Oh, did I call it device? Let's call it env. Let's see, sorry. So currently inject returns void, but I'm gonna change it so it returns the thing you inject. But, or maybe it doesn't matter. Maybe it doesn't matter. Why is this complaining? Oh, sorry, we just changed it, my bad. Inject env. And the point here being that we're gonna inject env. So now any nested component can, yeah, no, I think this would be confusing. Like I was just reflecting on this writing the docs, because now you think you can call inject env multiple times, right? Or well, yeah. Inject env. Yeah, no, let's try this. Anyways, and now we have a router with all the things. So let's move to the next thing. So the way you would consume this in other components is just env context get. Yeah. And then we have, I don't think mobile blocker. So this is nice, right? Mobile blocker is a completely static component. So we just keep it pure. So there's no like returning something like this because it doesn't have any state. So we're keeping it completely pure. And then we have app content. Is that here? Yeah, okay, now it's getting interesting. Let's see. Okay, so we have use authentication. You know, have you seen that? Is it Barack Obama who had like his shadow? He was doing like this speech at the White House Correspondents' Dinner or something, and he had this like very frustrated shadow because he comes off as so calm. It would be funny if I did a presentation of this and you would just be in the background just having these comments, like very sarcastic comments about everything I stated. Oh my god, that would be amazing. Okay, let's look at use authentication. How would we implement this? Using let's just change it. So we're gonna do create authentication. And what we're gonna do is create some state here. So let's call it state, create state, and it's gonna be the authentication state. Oh, look at me mistyping. Been clothing too much. Okay, so now we have our state. What's interesting, yeah, and what's also really, really cool that I didn't mention is that what we did here, so we can do these optimizations, right? Inferno is in an amazing piece of software, but there are a couple of things that you need. So one thing is like arrow boundaries. Inferno didn't have that, but we've been able to implement that using the context. But also, where do we have that information? Yeah, core concepts. Yeah, automatic batching, which is really cool. So this is something that came to React. Was it in React 18? So, and it's a very complex thing to get right. Or it depends on, well, it's technically unachievable. Because what you want is that you want to apply changes synchronously, right? So that your UI is consistent with your state. And the only way to do that is to synchronously apply state changes to the UI. In this case, reconcile the UI. Now, the challenge is that when you make that first state change, you don't know under the hood how many other synchronous state changes are going to be applied, right? You get the first one, you don't know if it's going to be more, so you kind of just apply it. And then you might apply a second and a third time synchronously, which is bad for performance. It's much easier if you apply it asynchronously, right? Because then you can take the first one, you can start a queue, a batch queue, and then on the next micro task, you just flush out that queue. So if you do multiple synchronous changes, the micro task triggers after that, and you flush them. So you have like one change. The problem is that now it's async, right? So you won't get a consistent UI. And typically this isn't a problem, but you'll notice it immediately if you're like in an input and you insert a character in between other characters, you see the cursor jumps to the end. So how do you actually solve this? And the way you solve it is that you have to know when it needs to be synchronous. You need like specific points in specific points where you explicitly batch synchronous updates. So the way that's done also in React and the others is that you hook into the event listener or into the event. So whenever you do an on click, on change, all the ons, what you do is wrap it in a batcher, right? Kind of like how Immer batches like mutations to an object and then applies it after you've done all your mutations. It's the same thing, right? You have an on-click, the on-click handler is wrapped in a batch, and all the state changes you make synchronously in that handler is going to be batched and then applied synchronously. So you do that and you do the async thing. So then all on-click or event handlers will synchronously apply state changes and batch them. And then you have async changes where you just, there's some state change that hasn't happened in an event handler. You queue it with a micro task, you collect all other state changes before that micro task triggers, and then you trigger it. And this is really, really nice to just have that in the solution. Okay, so I guess, yeah, so this one's interesting. So what we're doing here is that we're setting up this subscription and we're using an effect for that, but we don't actually have to do that. So we can remove the effect. Boop. We can just set up our on-off change. Let's see. Does it even have? Yeah, this is interesting because we have like different hooks for signing in and signing out. It would be really nice to have everything in one place. So we're gonna make that change. But one thing that's a little bit tricky is that it makes sense to me that we have create state like this, but this is a union, right? So we want to actually update the whole object every time we make a state change. So there's two ways to do that. Either you do like object.assign state like this, but that isn't typed. So that's bad. We could add a utility to like assign state, state, and that would actually be typed. And we could even like synchronously batch those changes, though we don't really need it now because of what I just explained. But yeah, or we can just take this and actually put it behind an object auth. So whenever we make a change here, we replace the auth. And I think that's the most like pragmatic way to do it. Let's see, state.auth. Yeah, I guess that's it. Let's see. And then we're going to clean this up a little bit. So we're going to move this whole thing. Oop. On off state changed. Let's see. Yeah, sorry. So this is going to be create cleanup. Oop. Like that. And then we're going to return state.auth for now. Wait, what's that? Function on of state changed. This is a user. Oop. Like that. Wait. Expected 1 argument, but got 2. Oh, sorry, I overrided the. Oh, that's annoying. There we go. Oh, or null. Cool. Yes, that's a given now. We do the cleanup. And then, yeah, let's just keep all the craziness here. Yeah, and then we can have, oh, this is interesting. Now we can do the n. We can do n context get. So we have n is electron. That's pretty nice. Yeah, cool. I think that's pretty nice. Okay, but that's like, that's just an authentication state. We also want to have the possibility to like sign in and sign out and all of this stuff, and we can put it into the same thing so we don't split up unnaturally. So we can do that as well. Yeah, let me just try that. Let's use sign in. Oh yeah, I'm doing some crazy stuff here. I built this other thing called pipe. It doesn't work that well. Let's see. Let's try to, okay, we're gonna do this last. And then I'm gonna reflect a bit on what we did here and how we're gonna approach it moving forward. But let's see. So we're gonna do create view state.auth and sign in. And we're gonna create sign in. So this could be its own thing, really. Maybe we can, oh, this is going to be nice. I didn't think about that. Oh, this is going to be super nice. So we can do, let's just call it const. By the way, is this using auth? No, it's not using auth, is it? No, it's just a pure thing. Okay, so let's do that. Create sign in. Let's do this instead. Yeah, and you know what? I don't think it matters that much here. Yeah, how are we going to do this? Are we going to have... Because there is an auth state, there is a sign-in state. How are we going to return that? Are we going to return it as... Well, we should really treat it as a mutation. Okay, let's try to do that. Let's see. So we're going to do... let's see. Oh, there's so much stuff here. We're going to do return create mutation. Because this is a mutation, right? You have an is pending. What's the state? You have an is pending. You have an error. And you would potentially have some params for optimistic, but you don't really do anything optimistic here. But what we're doing is this. Boop. Create mutation. Sign in with custom token. Google Auth provider. Sign in with pop-up. Track sign in. Yeah. Something like that. And then we also have this, we're waiting 5 seconds. And this has to do with the authentication. Oh, this is interesting. We could actually handle that now. Oh, that's pretty cool. So this delay here is because it doesn't move into authenticating when you finish the sign-in. That can happen a little bit later, so you get this like flashy UI. So we want to make sure that we move into authenticating when we have a successful sign-in. So let's remove all of this. Yeah, maybe this is, we don't need this. We can just put, don't need to put this into its own thing. We can just say const sign in mutation, create mutation, sign in, and let's create sign in. Oh, sorry. Boop. Yeah, so yeah, that's a good question. So since we're putting auth here nested like this, you can safely destructure it. It's only like, what's it called? Plain values. What do we call them? Literals, like strings, numbers, booleans. You can't destructure those, but you can destructure objects because objects themselves are proxies. yeah, so what's kind of cool here is that I can just say state of is equals let's see. Yeah, because we're signing in, so we definitely don't have a user. So we don't have an error. I can say, and we don't have a profile, and we don't have a user. This is pretty nice. So now we can say, so immediately as the this mutation resolves, so it's not like pending anymore, we're gonna have is authenticating true, which is gonna be nice. And it's gonna be true until this other thing resolves. So this is actually super, super nice. And then we're gonna sign in. The only thing I don't like about create mutation is that you have sign, like there's a reason why it needs to be, oh sorry, sign in is sign in mutation. So sign in mutation. The good thing about create mutation is that you get actual reactive properties you can use in your UI for free, right? That's the reason it's there. But that also means you kind of have to call mutate on it. But maybe it would make more sense that create mutation is just a function. And the query can be the same, actually. So that you have actual sign in like this. And then the function is pending. So you add the properties to the function instead. That feels much more natural to me. So you just enhance the function type. The bad thing about that is that a function has a lot of other properties, right? So you would kind of add is pending and pending params and error to this. But I think that's better than having to call like sign in mutation, mutate. It just doesn't feel right. And for the query, you would then have the same thing. Like user query would be an actual function, and you can still check is pending. You can check its value. It's kind of like what we're doing with promises as well. But it looks nicer on the query because you can say fetch. But mutate, it's like, ugh. Yeah, I'm not sure. I'm going to reflect on that. Yeah, it's like you're pointing to like auth dot sign in dot mutate. I don't like it. Yeah, and you, well, yeah, and the cool thing is actually, yeah, the nice thing is that you can override the typing so that, no, you can't, because then it doesn't understand that it's a function. Yeah, it's interesting. Like you need to have, is it just a symbol constructor? Is that all you need? Maybe it is. For it to treat it as a potential function call. I don't know. What does TypeScript need to allow you to do that? Yeah, I can check that. Anyways, so now we have sign in together with the actual auth listener, and we can do the same thing with yeah, link anonymous account, sign in anonymously, test sign in. All of this can be like one module, which is nice to have it together. Okay, but what did we actually do here? So one thing we did is we didn't have to use an effect to set up the subscription. We could just set it up. Yeah, we moved the state in like this, talked about how you can use a nested property for unions so that you replace the whole property every time you change this specific state. I think that's fine. I'm kind of hung up on unions. And then we added a mutation for the sign-in so that we get free pending states for it. We talked about potentially changing the signature of mutations and queries to just be the function. And we were able to resolve this issue where I had this like artificial delay of 5 seconds. Yeah. I think that's it. And then I think this is also going to have a context, because we're going to need that authentication in other places of the code. So let's do that as well. So maybe we should also call this create authentication. Inject authentication. Yeah, we don't have to do that now. I have to drop off. But yeah, this was it was nice to go through this. I'm not sure if really the best way to kind of show the library is to do a refactor. But it's a really good way to test the library. So yeah, I'm just going to do that for now. I'm going to do, yeah, I'm not sure how I'm going to approach this. I have the slides and I can do a much better job of presenting those slides. Make a video, upload it on YouTube. Yeah. I really like to have some actual proper success stories before like publishing anything. But that's gonna take some time for me to refactor this. Hello. Hello. Sorry, I was just finishing up here. But yeah, I'm gonna reflect on that as well. Because one thing is publishing something is to get actual feedback. But it also puts you into this maintenance mode and things can get a little bit stressful. Maybe some bad decisions were made and it's very hard to change them. And then you can release it as like a release candidate, but it's not like really properly tested. Like there's a bunch of tests, but I haven't actually written an application with this. It's like just experience and like an intuition and all of this. Like I know it's much better than what I'm used to, but there might be some edge case bugs. Yeah, no, I have to think about this. I have to do it. Okay, bye for now, and I'll do another stream, hopefully during the weekend. And yeah, maybe I should. Okay, I'm gonna try to wrap up my thoughts. I'm gonna make a video that goes through the slides as like a presentation of conceptually what this thing is. I'm also gonna do like a video where I'm building like something simple, like a to-do app kind of thing, which kind of gets you into the actual syntax. And then I'm just going to continue. Yeah, and then I'm going to continue refactoring the app. And I will not even evaluate releasing it until I refactor this app. So if this app is running well, then it's all good. And it's not that much to refactor. Like the app, it's the same JSX and everything. It's running Tailwind CSS. Like it's the same thing. I don't have any special components there. Everything is like manually built. So that's going to be just fine, I think. So yeah. So those are the activities. And then at some point in the future, when this is properly refactored, we can evaluate if we're going to actually release it. Yeah, maybe I can make like a video. Yeah, that's what I'm going to do. I'm not going to introduce the library as, hey, this is a new library. I'm going to create a video for feedback and then point to the GitHub repo. People can write issues, invite them to test it, and so on and so on. And then just be honest about like just refactoring a big app, and we'll only release it based on that experience. Something like that. Yeah, it's an experiment for now. The good thing is that it's built on Inferno, and the reactive primitives that we've implemented many times before. So the parts aren't experimental. It's just putting it together. That's experimental. Okay, cool. I guess we'll speak soon. Bye for now.